Remember when I told you no matter where I go, I'll never leave your side, you will never be alone. Even when we go through changes, even when we're old, remember that I told you I found my way back home.
Introduction. Under this, we have 8 subtopics. So first one is the water quality, second is the physical characteristic, third is the chemical characteristic, fourth is the microbial characteristic, and the fifth is a radiological characteristic. We also have water quality standards, water classification, and the last is the treatment system. So let's start with the water quality. The following 4 categories are used to describe drinking water quality. So the first one is the physical, second is chemical, third is microbial, fourth is radiological. So let's discuss what is physical characteristics. Physical characteristics includes turbidity, color, taste, odor, and temperature. While chemical characteristics includes first chloride, second fluoride, iron, lead, manganese, sodium, sulfate, zinc, arsenic, toxic inorganic substances, toxic organic substances, microbial characteristics. Water must be free from disease-causing organisms such as viruses, bacteria, protozoa, and helminths. Most widely used tests estimate the number of microorganisms of the coliform group. There are 2 genera, namely the E. coli and the Aerobacter aerogenes. The name of the group is derived from the word colon. While E. coli are common inhabitants of the intestinal tract, Aerobacter are common in soil, on leaves, and on grains. And on occasion, they cause urinary tract infection. Radioactive characteristics. Concentration intake of radioactive substances, including water, must be unlimited, since radiation and radioactive materials are harmful to humans. Now, let's go on with the water quality standards. Environmental Protection Agency, or EPA, was directed to establish maximum contaminants level, or MCLS, for public water system. From 1975 to 1985, the EPA regulated 83 contaminants of drinking water supplied by public water system. These regulations are known as the term Primary Drinking Water Regulation, or the IPDWRS.
Here, the number of regulated contaminants from 1976 to 2000. So, 1976, they regulate about 22 number of contaminants, and it goes to 91 contaminants as of 2000. The data source is the United States Environmental Protection Agency. So we have here the list of each regulated contaminants and summarizes its adverse health effect. Can be found in the book of Introduction to Environmental Engineering, 5th edition by David and Cornwell, page 261 to 264. So one example of this, we have a long list of regulated contaminants and its adverse effect, but one example of this is benzene. Can cause cancer, and the source of drinking water contaminants are food, gas, drugs, pesticides, paints, plastic industries, and so on. So I actually have a long list here. Yeah, that's it. We have also chloride and a lot more. The next thing we have in here is the secondary maximum contaminant level, or SMCLS. So under this we have aluminum, chloride, color, copper, corrosivity, and yeah, the effect of it for the aluminum colored water. So that's the effect of it. That's our secondary maximum contaminant levels.
For our water classification by sources, we have potable. Under this, we can get potable water from groundwater or surface water. Groundwater includes deep wells and shallow wells, while surface water includes lakes, reservoir, and also river. For treatment system, so we have the classification of treatment system. We have disinfection, filter plants, and softening plants. Simple chlorination for groundwater sources that have high water quality. Chlorinate to ensure that the water reaching customers contains safe bacterial level. Adsorption, ion exchange, or precipitation is to remove contaminants such as arsenic, fluoride, radionuclides, iron, or manganese, while aeration is to remove spills from contaminated water caused by humans.
This is the flow diagram of conventional surface water treatment plant or filtration plant. In filtration plant, rapid mixing, flocculation, sedimentation, filtration, and disinfection are employed to remove color, turbidity, taste, odor, and organic matter, and also bacteria. Additional operation may include barracks, that one, or core screen if floating debris and fish are a problem. So you can see here a typical filtration plant. So the raw, untreated surface water enter the plant via a low lift pump or gravity. Usually screening has taken place prior to pumping. During mixing, chemicals called coagulants are added and rapidly dispersed through the water. The chemical reacts with the desired impurities and form precipitate, are also known as flux, that are slowly brought into contact with one another during flocculation. The objective of flocculation is to allow the flux to collide and grow into settleable size. The particles are removed by gravity or sedimentation. This is done to minimize the amount of solids that are applied to the filters. For treatment works with high quality raw water, it may be possible to omit sedimentation and perhaps flocculation. This modification is called a direct filtration. This is the filtration. Filtration is the final polishing or removal of particles. During filtration, the water is passed through sand or can be similar media to screen out of fine particles that will not settle. We also have disinfection. Disinfection is the addition of chemicals, usually chlorine, to kill or reduce the number of pathogenic organisms. Storage may be provided at the plants or located within the community to meet peak demand and to allow plants to operate on a uniform schedule. A high lift pump provides sufficient pressure to convey the water to its ultimate destination. The precipitate chemicals, original turbidity, and suspended materials are removed from the sedimentation basin and from the filters. These residuals must be disposed of properly.
So we have here the flow diagram of water softening plant. Softening plants utilize the same unit operation as filtration plants, but use different chemicals. The primary function of softening plant is to remove hardness, such as calcium and magnesium. The design consideration of the various facilities are different than those in filtration. Also, the chemical doses are much higher in softening, and the corresponding sludge production is greater. During rapid mixing, chemicals are added to react with the precipitate, the hardness. Precipitation occurs in the reaction basin. The other unit operation are the same as in a filtration plant, except for the addition of carbonaceous step employed in softening to adjust the final pH. Softening plants sometimes have two reactions in settling tanks in series. And that's our softening plant. Now let's proceed to the overview of typical processes used for contaminant removal in some of the parameters that may be adjusted by chemical addition. Under this, we'll talk about alkalinity, arsenic, barium, cadmium, chromium, color, fluoride gases, iron, lead, also pH level, manganese, mercury, nitrate, radionuclide, taste, and other total organic carbon or the TOC. Alkalinity. To increase alkalinity, generally, lime, caustic, or soda ash is added to the water. For our arsenic removal, you can use adsorption to filter media coated with iron or titanium. Chemical oxidation with chlorine, potassium, or manganese dioxide for filtration through green sand or other proprietary filter media. Coagulation with ferric chloride or allium, followed by settling and filtration. Or anion exchange, electrodialysis, membrane filtration, and lime softening. Barium can be removed effectively either by lime softening at pH of 10 to 11 or by ion exchange with a sodium regenerate cycle. Cadmium. Greater than 98% removal of cadmium by lime softening in pH range of 8.5 to 11.3. Ferric sulfate and allium coagulation have also been used, but their use is not as effective as lime softening. Chromium can be removed easily using allium or iron salt and by lime softening. Next is color. Oxidation with chlorine dioxide, oxygen, or potassium. Fluoride can be removed during lime softening if the magnesium concentration is high. Gases. Dissolved gases that may be found in groundwater includes hydrogen sulfide, carbon dioxide, methane, and volatile organic chemicals. Stripping of these gases is normally accomplished by tray aeration, back tower aeration, cascade aeration, fountains, and spray nozzles. Iron. Dissolved iron, or Fe2, must be oxidized to Fe3 before it can be precipitated and removed by sedimentation and filtration. Oxygen, chlorine, ozone, and chlorine dioxide, and also potassium permanganate have all been used as the oxidizing agent. Lead can be removed by ferrous sulfate addition at a pH of 7 to 9, ion coagulation at a pH of 6 to 9, and lime softening at a pH of 9.5 to 11.3. Next is manganese. Manganese, or Mn2, is a dissolved form. Like iron, it can be oxidized to Mn4 in order to be precipitated and removed from the water. Mercury. Inorganic mercury can be removed using coagulation with ferric sulfate at pH of 7 to 9 and by lime softening at pH greater than 11. So granule and powder activated carbons are effective at removing organic mercury from water. Next, we have the nitrate. Anion exchange, reverse osmosis, and nanofiltration, and electrodialysis or treatment processes recommended for the removal of nitrate. Next, we have the pH. Often, the pH of the water must be adjusted by adding either an acid or base. Sulfuric acid and phosphoric acid can be added to lower the pH, whereas lime and caustic soda is added to raise the pH. Radionuclide. The best available treatment for radium-222 is aeration, while combined radium-226 and radium-228 treatment consists of coagulation and flocculation. When radium-222 and 228 are removed separately, ion exchange, reverse osmosis, and lime softening are the best technologies to use. Uranium is best removed by ion exchange. For the taste and odor, activated carbon is the most effective means of removing these compounds. Chlorine, chlorine dioxide, copper sulfate, aeration, and ozone are treatment processes that can be used for removing taste and odor compound. Next, we have here the carbon. Can be removed by lime softening and or coagulations. However, coagulation is more effective than just using lime softening. Coagulation. Coagulation is a unit process consisting of addition and mixing of chemical reagent, can be coagulant or flocculant, for the destabilization of colloidal and fine solids that are suspended in the water.
Now we have here the schematic of coagulation and flocculation process. So you can see coagulation process is from here to here. So from rapid mixing, destabilization, it will also include flocculation. So that's it, and the rest is sedimentation and filtration, which we'll be talking about later.